Good afternoon. Thanks for joining. My name is Suresh. I'm Director of Engineering at Oath, and this is Nandhakumar. He's my colleague, part of my team. How many of you know about Oath? What is Oath? Good. Someone is raising my hand. Happy about that. So Oath is an entity which was formed after Verizon bought AOL, Yahoo, and a bunch of other companies and merged into one unit called Oath. So technically, I'm an ex-Yahoo now. Today, we will go through our experience. We have been running Kubernetes for almost 2 years now. We will share our experience. What are the outages, issue which we ran into, and then what's the lesson we learned out of it. So I am part of the core platform team. I lead the Kubernetes effort at Oath. Most of media products such as sports, finance, and you can talk homepage, all these stacks are currently served out of Kubernetes. Okay, if you access yahoo.com page or sports page, it's completely served out of Kubernetes stack today. So my team manages the Kubernetes cluster and the tools around Kubernetes cluster. Not only this, we do have other tools which kind of helps improve the developer productivity and velocity of release. We do a bunch of things which we call the platform team, not just Kubernetes. This is my team. You guys see the flag, Kubernetes flag. We really love Kubernetes. I cannot explain more than this flag, right? A bunch of guys are missing here, but pretty much the entire team is here. And you can see here we have Grafana dashboard out there. So we extensively use Grafana Prometheus for monitoring. Tomorrow we have a talk about how we leverage Prometheus for monitoring at 2:45. Please do join the session. Okay, where are we today, right? We are in production, like most of our applications are running in production with Kubernetes today. We have 12 clusters, production grade cluster, distributed across 6 regions. And we have Anycast routing, which routes a user to the closest data center based on where he comes from. And we have 2K plus worker nodes in a cluster, and 20K pods, 50K containers running out there. And we have 200 plus application running here. And at the peak, pretty much we do is 400K RPS, like this particular stack does. And we do most of the application which deployed today is stateless. When I mean stateless, it's not storing any state. So when you access yahoo.com page, there's no state stored there, right? And we are exploring stateful applications such as Redis clustering and Cassandra as we speak. We will definitely share more in upcoming KubeCon conference. We are building an operator, Redis operator, which tries to manage the Redis cluster for you for all stateful workloads. Okay, let's go through a little architecture, how this looks like at Oath today. If you look at your right-hand side, right? We have something, the orange boxes are the one which the component which we built for bringing in Kubernetes to Oath. And the green are the existing Oath services which we leveraged. And the other thing you pretty much know, this is from Kubernetes stack, kubelet, API, scheduler, and things. Let's go through it. To your right, we have custom ingress controller. Right? So you pretty much know Nginx and Envoy and things. Here we use Apache Traffic Server. So Apache Traffic Server we have so much dependency on Apache Traffic Server. It used to be Yahoo Traffic Server. When it's open sourced under Apache license, it became Apache Traffic Server. We have lots of plugins which we have dependency on Traffic Server. So we have to build our controller, ingress controller based on Apache Traffic Server. Over here, so you can see there's an agent running in the controller. What it's trying to do is it likes to look for the Kubernetes API. It hooks to Kubernetes API, looks for the endpoints, gets those IPs for the origin, for where you have to route the request to, and pretty much dynamically load into the ATS. It does all in memory. So you can think of here like, hey, we have 400K RPS coming in, and there are pods getting added, removed, deployments are happening, the IPs are getting changed. We need to seamlessly load this information to the ingress layer. We cannot reload or restart the ingress, which pretty much it will kind of impact your live traffic, and your long tail latency will go up. So we pretty much build this ingress such a way that we do in memory, so there's no impact to the live traffic. So that's on the ingress controller which we have built. And if you look at your left over here, custom tool. Let's talk about Screwdriver. Screwdriver is an open source project from Oath. This is our CI/CD platform. So we build custom tools on top of Screwdriver. What this custom tool does, right? When we want to bring Kubernetes to Oath, right? We don't want every engineer to completely understand the entire Kubernetes spec. So we provided a simple interface, a single YAML file for an user. So in that YAML file, he pretty much says that I want to deploy this particular image. That's it, right? And then some sane value in terms of CPU and memory. And what we do, we have our own templating engine. We take that file, a simple interface, and we convert into a bunch of Kubernetes YAML files. That bunch of Kubernetes YAML files like ingress, service, deployment, and then we natively apply using kubecon to any cluster which we built. That is the customs tool which we built. This enabled us to rapid onboarding to Kubernetes because the interface was very simple. The engineer could understand the simple interface rather than forcing an engineer to understand every aspect of Kubernetes, all the resources of Kubernetes. And over here, we built an auth hook. This is our authentication and authorization hook. It is integrated with Athens. It's pretty much open sourced as well, and you can find it out. Athens is similar to IAM in AWS world. So this hook, pretty much when you execute any command against the namespace, any user or the admin, it checks whether you are authenticated using a valid. We have our own authentication mechanism. And then it checks again whether you are authorized to do that action on that particular resource, on that particular namespace. This is the level of granularity of policy which you can define in Athens. So these are pretty much components which we built and leveraged to get Kubernetes into Oath. So let's go through how do we build pipeline, right? So our base Kubernetes cluster itself, right, is built using Chef. So our remaining everything, like in the add-ons and application developer who's deploying their application, they use Screwdriver and the custom tools. But the base Kubernetes cluster is built using Chef. So we pretty much write the Chef runbook, and we push the changes to stage, we bake in there, and then we push the changes to Canary. From Canary, we push the change to production. It's like if you need anything to override specific environment, you can go and update in that particular environment the override files. So this is how we change the Kubernetes changes, the Kubernetes base Kubernetes changes. Okay. We are operating on-prem, right? We are not in EKS or AKS, so this is pretty much my team managing this. Kubernetes is awesome. We all love it, right? In fact, I always said I really kiss Kubernetes all the day, right? But there are many interdependent components, which is very hard, right? When you try to operate Kubernetes on your own at the scale, right? You can talk about etcd, controller, scheduler, API, kubelet, Docker runtime, what all not. There are so many control loops which you need to understand when you try to operate that. So, okay. Then when we try to manage and we try to scale, we ran into many issues. It could be human error, Kubernetes bug, then how did we fail and how did we recover? We will go through that now. One of the first, human error, right? Namespace, right? I told this is a single cluster, right? This is soft multi-tenancy. When I say soft multi-tenancy today, it's like there's not, this is a team of bigger team, right? Every team gets their own namespace. They don't get a separate cluster. They get their own namespace for them to operate, right? So only it is sensitive workloads, then we have a separate cluster for them. If not, it's pretty much they share the underlying resource with their namespace isolation, right? So in a given namespace, you have 100 plus deployments going on. So what does this command say? kubectl delete -f directory. You are deleting pretty much whatever there in that particular directory, all the resource. So one of the cluster admin, he was trying to operate against non-production environment. His context was set to non-production, okay? And then he was thinking that it was set to non-production, and he tried to delete this directory, right? And sorry that he was pointing to production, and he executed this command against our production cluster, right? In this case, one of the file in that directory was namespace. So you pretty much deleted a namespace which had 100 plus deployment. When you delete a namespace, what happens? You guys know that it's pretty much, it wipes out. What he's trying to do is like, okay, here you go. it has a cascading impact. Like what happened was like all the deployment and pod, everything within that namespace came down. Like everything was deleted, right? And there is no way for us to stop that because the command has been executed, right? And now, like, hey, how do we recover that? The impact has been done. It's like, hey, you executed the command, the deletion is happening for the pods and deployment and all the resources within that namespace, and then the namespace finalizer will clean that namespace, right? No, nothing can be done. It's kind of complete outage. But that particular namespace, which was serving a critical workload, on that particular data center, it was complete outage out there, right? How did we recover? Okay. We do, as I was mentioning, we failed out that particular data center so the user can go to the next data center available. That's easy, quick way to do that. And then we worked with our tenant saying that, hey, we apologize, we made this mistake, we deleted your namespace and your deployment. Can you please re-trigger your deployment? And they went and re-triggered their deployment and the things came in, right? But we observed like, hey, this accident could happen. Like, how do we prevent it from happening, right? So we have admission control. In Kubernetes, there is an admission controller, right? It's pretty much, you can validate, there are two types, it's mutating and validating, right? You pretty much validate an object before you take any action on that particular resource. So in this case, we build this an admission controller. What this admission controller does is, pretty much if you run an operation delete on the resource namespace, that object call is passed to this admission controller. What this guy do primarily is, it will check if you have any other resources within that particular namespace. If you have pod, or if you have deployment, if you have stateful set, ingress, it will try to prevent you from deleting the namespace. It will say you, please go ahead and delete all those resources, and then come back and delete your namespace. Then we know that this action is being deliberately taken by the users. It's not an accident. Okay? This is one way we prevented this kind of accident happening. And again, we also provide administrator key. Only they can force delete it so that we're not forcing all the tenants. So if we have a special key, which we know of, if we pass that tenant, this hook will not be executed. This is for our convenience in case we run into any kind of corner cases. The next issue which we ran into, okay, I said we had a single ingress controller, right, today. So we made everything self-serving, right? Everyone just comes in, creates that single interface YAML file. We convert that into Kubernetes file, and we apply the change using kubectl, right? kubectl. So ingress resources used for you to say that, hey, onboarding to Kubernetes, saying that with this domain name or host name, we can call that sports.yahoo.com, right? And then this is the backend I need to route to, right? This is how you onboard to Kubernetes and create an ingress resource. You can think of this one. What's wrong in this particular things, right? So one of the effective tool in engineering world is copy-paste, right? And clone, right? In this case, what happened was there's two ingress resources created by two different tenants, okay? And they were pointing to different backend. This is app 2 and this is app 1, but they claimed the same alias, which is the same host name, right? So now what happens is you pretty much took someone else's domain name, right? And pointing to two different backend. So what happens during this case, if any of the ingress controller right now, when it tries to get a request and then it has two backends for the same domain, right, it will try to round robin between those two backends, right? So you can think that I'm accessing sports.yahoo.com, I'm getting finance content because it's pointed to the finance backend. And if I refresh it, next time you get a sports content, right? So this is because of accidentally copy-pasting or cloning someone's Git repo and then trying to send a PR out of it, right? We would like to avoid this from happening. And this is also very bad user experience. So yeah, most of the ingress does round robin. So we built another admission controller, which we called ingress claim, right? But what these guys do is, like, if you have a domain name or a host name is being claimed by some other namespace or some other deployment, it will not allow you to claim it back. It validates it and say that, hey, this particular domain name, for example, sports.yahoo.com, is being used by sports team. Okay, you cannot claim that. We try to avoid this. We put a prevention out of it, right? This is a nice way for avoiding anyone from hijacking each other's domain. Okay, scary moment. So we do have an experience where, like, hey, I'm accessing sports, I'm seeing all finance content, right? And then it's like, that's bad. So again, the same thing. Whenever you create an ingress resource, create an update, and we pass that call to the ingress claim admission controller, where it validates it, and you're not copy pasting, or you're not duplicating the same domain name, and it denies in case you are claiming a domain which does not belong to you. Okay, this is next, we kind of major things which we solved. Next thing is Kubernetes node, right? So we are making changes, we upgrade. We started with 1.6, and then now we are in 1.9. 1.5 we started, pretty much. Now we're in 1.9, right? So we did lots of upgrade. So one of those changes are, we were trying to make a change to kubelet, and we were trying to roll it out, right? And we are trying to roll that out, and then we ran into this Kubernetes bug. So what has to happen is when the kubelet, when it's trying to restart it, so it creates a transient C group file, and it cleans up before it starts up, right? So this is a clean way of starting for kubelet. So because of this particular bug in Kubernetes, the kubelet did not start, right? And our rolling update of kubelet change went across the fleet in one particular cluster. So what happens when the kubelet is not coming up? What does Kubernetes API thinks? The node's bad, the nodes went down. So in this case, 100% of the node were in a not ready state, right? Cool. All the nodes are not ready, the entire cluster of nodes are not ready. Looks bad. Let's see what happened, right? You can see this red line, like it's great, everything is happening, and in this red line, see that this number of nodes which are getting into the eviction queue and being evicted, this line grows up. Right? And then you can see that everything comes down, and this guy goes up. This is scary, very, very scary, right? When a node might be himself as not ready, right? What does the controller does? The controller puts that node into an eviction queue, and it will try to evict that pod from that particular node so that it can be scheduled in other available nodes, right? So it started doing that when it observed the node when it didn't happen, right? This exactly happened. So this is a very cool feature in Kubernetes. I'm not sure how many of you know this particular feature. It's not that much well documented too, right? So when the controller observes it's 50% of the node in a cluster is not ready state, it makes a smart decision. It says that there's something wrong with the cluster, so let me back off, right? It backs it off, and then it says that in the throttling rate, in terms of eviction rate, instead of doing every second, it will make every 15 seconds, every 20 seconds. It will try to slow down the eviction of the pod from the node, right? This prevents, right? You cannot evict everything, right? If you evict everything across the cluster, where will this go? Because all the nodes are not ready state. Everything will go in the pending states, right? And fine, we still had an impact, like 50% of the node pods are evicted. They're still getting scheduled in the remaining set of hosts. It's not scheduling, it's just going in the pending state because there is no node is ready. Same time, when the controller observes that 100% of the nodes are down, it enters into something called full disruption mode, right? In this particular mode, what is trying to, it will stop evicting, which is great. This is what we want, right? The thing is, the communication between kubelet and API is broken. It's not the communication between the ingress to the pod, right? We still had that route working. The pod was up and running. Just the kubelet, the process was down, right? In this case, we had a degraded experience because 50% of the pod got evicted. Remaining 50% we were able to sustain because Kubernetes entered into this particular mode. Okay, it's a pretty cool, awesome feature in Kubernetes. It's not well documented. You can take a look at that. Okay, what we did. Okay, quickly to recover, because we had a degraded experience, it's not that completely down, right? Because we have many data centers and many clusters, we failed over that particular data center, and every user went to the next data center. That's pretty cool, we did it. And we do update a 30% concurrency. We don't want to go across the fleet, right? We do that. But what is one of the lessons which we learned out here is, please do a test after upgrading kubelet, right? A simple curl command against kubelet's API is sufficient, right? We did not have that, right? And then what happened was like, there's no functional test post-upgrade, it all came down, right? It's a very good experience. We learned a lot during this experience. And now we pretty much, when the kubelets get updated, we have a framework, testing framework, to make sure that the kubelet is certified before the next 30% of the batch is being picked up. Okay, this is a very cool experience. etcd upgrade. How many of you guys done etcd upgrade? Wow, a lot, right? Scary, really scary, right? And this is something which we did in our canary environment. So we want to upgrade etcd from one version to the next version. And one of the things which we did was we left the Kubernetes API up and running during this process. Okay, fine. We will take the etcd down. The communication between the API and the etcd will be failing, and it's not going to take any action, right? Okay, we ran a script, okay, which will go and upgrade the etcd and puts back into rotation, right? So that script had a bug, okay? When it tried to upgrade it, and then when it came up, in the production, it's supposed to point to a production directory. Somehow the script had a bug. It detected that as a non-production environment and pointed to a directory which was empty, because that's not a production environment. So the kubelet, the etcd started with an empty directory. What happens now? The cluster was up and running with 100+ deployments, right? Now the etcd we bootstrapped with an empty data set. Okay, what's the behavior will happen? Sorry? Complete wipeout, great, right? Yes. So what happened here, now that API was able to connect to etcd, okay, and the kubelet came up, and then he's trying to connect with the API, and the API say that, hey, I have 100 parts. Then the API said that, no, you're not supposed to have 100 parts. Per my data source, okay, you are supposed to not to have any part. You should be clean. So what happens across the fleet, all the kubelet, it'll evict all the part. It self-evicts all the parts. Clean slate. The cluster was complete down, right? This is awesome. This is really awesome, right? Okay, fine. This is a mistake. This is a script bug, right? It's supposed to point to production directory. It pointed to a non-production directory, which had empty in production cluster, right? It came out empty. This is expected. What I really expected, like, how did we recover? Let's go through how we recovered, right? Okay, yeah, we pointed to the right directory. There's no rocket science here. And also, we periodically take a snapshot of etcd store, and we took that snapshot and stored into the directory and recovered that. Once you put the data back, now the kubelets synchronize with the API, and the API says that, hey, you're not supposed to have this part per the source, which is etcd. Now everyone started scheduling this one, right? I really, really like the feature. It's like, hey, we want Kubernetes API to know that, hey, we are doing some kind of maintenance. There should be a flag in Kubernetes API, which we are also exploring, which says that I'm right now in maintenance mode, do not sync, right? So I opened a bug against community, and we are discussing there where it's like, hey, I'm in a maintenance, do not sync. So this kind of accidents could be avoided. Cool. I'll hand it over to Nanda to go over a few more scenarios. There are so many. I said, we have run for 2 years. There are so many bugs which we ran into. I cannot cover most of them. I'll try to cover major things, okay? Go ahead, Nanda.
Thank you, Suresh. TLS certificate and refresh. How many of you have done TLS certificate rotation of your existing Kubernetes cluster? Some quite brave hands there. All right. So the reason why we do a periodic TLS certificate rotation for the Kubernetes clusters, the primary reason being is that it's a self-signed certificate, and it's also short-lived, close to 1 year. So what happens when we do the TLS rotation? Pretty much the whole Kubernetes control plane components needs a restart. The kubelet or etcd or control manager, the API server, all these components needs to be restarted to avoid communication between these components. And there's one another component called service account, which is a special. Service account tokens are created by controller manager by using this private key, service account private key, and the Kubernetes API server authenticates that service account token using the corresponding public key. The reason I'm saying it's special is that almost every controller in the Kubernetes ecosystem uses the service account to authenticate it. And we wanted to rotate that also frequently. The reason being the service account, once you created it, it's a never expiry token. So to address those security situations, we often rotate the service account private key as well. So one thing we observed when we actually rotated the certificate, this private key, that all the controllers stopped working. Like horizontal pod autoscaler stopped working, daemon sets controller stopped working, deployment controller, everything. And including all the add-ons like a Heapster, kubedns, and everything. And it also had some impact to our existing applications where we had an identity D component which watches the Kubernetes API. That particular communication is also broken. So the way we resolved was that we restarted or kind of recreated the service tokens and restarted these affected components, and they started working perfectly. And when we overlooked it, the API server service account key file had an option that it could support multiple public keys. So if you are in a situation that you have to rotate the service account, the public key, so you make sure you add both the certificates to this component and restart the API server, so you could potentially avoid the catastrophic situation that happens at that time. But you really wanted to phase out the old service account tokens because it's a non-expiry one. So that you can do actually in a controlled manner instead of rushing to it. So this is one of my favorite components when it comes to a Kubernetes ecosystem because it has a huge integration between the applications running on the Kubernetes cluster as well. Almost every pod, majority of the end user pods running in the Kubernetes cluster uses the kubedns as a resolver. There are a bunch of cases we ran into problems with the kubedns, namely, oftentimes not all the application pod have a DNS cache built in. So they make, for every DNS lookup, they make a call to kubedns. If you have an application that has 1,000 or 2,000 pods, and when they have a deployment going on, this potentially can bring down the kubedns pod. And there's another interesting thing. The second thing to note is that whenever there is a kubedns pod goes down, kubedns runs in a deployment, right? So pod can go down. So when the pod goes down, kubeproxy updates the endpoint controller saying, hey, just remove this particular endpoint. And so every machine in the cluster gets a new update of final set of Kubernetes kubedns endpoints. So even during this fraction of a minute, you would probably see a DNS latency in your applications. And there is one another critical thing is because we run in an on-prem, so we don't throw the host away. When the host goes down, we wait for that host to come back, right? So oftentimes a node goes unresponsible. During that time, if that node being the kubedns pod running there, then we have another interesting problem there that there is a flag in a controller says pod eviction timeout. It's default to 5 minutes. So for the first 5 minutes, it's not going to remove the failed node or the failed pod from the endpoint. So for 2 to 5 minutes, you will see all the application routing to the failed kubedns pod, thus having some outage on the DNS. How many of you know .file lookups here? Yeah, it's pretty interesting. So that's one of the cause in Kubernetes that it adds a latency for external DNS lookups. It has to traverse through all 5 lookups before you make a DNS lookup for an external endpoint. When I say external, which is not in your cluster.local. So all these problems we wanted to avoid. So one way we thought we could resolve this issue is we try to narrow down the pod eviction timeout. How much we can go thinner, right? So because we're on-prem, we don't want to be getting a false alert. So we tried an alternative approach, running a daemon set for the DNS mask, so that every node has a DNS mask. So all the external calls will be routed. So we have a rule in the DNS mask, so the external calls will go directly from the node, and it'll forward the DNS query to the cluster DNS only for those cluster.local DNS lookups. So that way we brought down the impact to narrow to a specific node instead of the cluster-wide impact on the other case. And also we make use of the cluster proportional autoscaler. So in case like we keep adding machines, right? So for the applications, we pretty much make use of horizontal autopart scaler. So for the kubedns, the more workloads we add into the system, so we make use of cluster auto proportional scaler. So hey, we got 10 more nodes, probably add one more DNS pod into the ecosystem. Running an on-prem is definitely a challenging thing because as Suresh mentioned, we had the SHEP pipeline, we have a robust release cadence and everything. But on the other hand, as even Aparna mentioned in the keynote today, Kubernetes releases almost 2 to 3 times major releases in a year, right? Keeping up to date with those releases is often a challenging task. And often we ran into an issue where, hey, there are some flags depreciated. This is a breaking change. You may have to make things. So just wanted to make sure that, whenever you're doing, don't file up those releases. Keep whenever you get a major release, keep a practice of upgrading to the major releases. And we have also bitten by a couple of operating system packages. So we tried. What I recommend is try to keep those kernel and operating system packages up to date. Like there were a couple of scenarios where dbus daemon was, doing a file descriptor leak, and the whole Docker communication was broken. We are getting a Slack communication say, hey, the sporadically, bunch of nodes on the cluster was throwing out for a Docker issue. So having up to date on these packages would help. So it's a pretty interesting problem in a multi-tenant environment. As Suresh mentioned, we have a namespace isolation, right? So whenever there is an OOM happens, C group is going to notice that and is going to kill that process, right? When that happens, it's going to dump a lot of information into the console. And occasionally, unfortunately, in our setup, console is a serial port, and it's a 9600 baud rate in our setup. So during that, the logs are written into the console. The CPU were totally choked off. It's effectively impacting all other applications running on that particular node. So we took an approach of step measure of reducing the less verbosity on those on the kernel verbose output. It's a pretty interesting feature in the Kubernetes, like Suresh mentioned. Node controller has a nice feature about the eviction throttling, and on the kubelet side, in a multi-tenant environment, right? As we mentioned, we have 2,000 nodes. We do get only 3 to 4 pages a week. The way we achieve it, we silence some of the pages through some of the cool features available in the Kubernetes. One feature, as I mentioned, just is out of resource handling. The way it works is if you have a tenant and if you have a user causing a disk phase to fill up, could be on the node.fs or on the empty directory volume. It could be even in the Docker image, image directory itself. You don't want to be woken up in the 2 a.m. and just for getting a disk full. The same thing could happen in you have more nodes available. If there is a memory pressure, you want it to make sure, you don't want to get alert for, one node alert. So this is a cool feature. What we can make use of it, basically configure the eviction threshold. So when this particular limit hits, kubelet ranks the pod, and it automatically evicts the bad pod, so that you don't want to be woken up in the middle of the night to solve this one single node issue. So it's a game day testing. So we often conduct a game day testing for our Kubernetes environment. So what I mean by game day testing is basically we break every component in a controlled environment. So we break it and we'll record those output. And so we pretty much do that for all the control planes, like API server, bring down an API server and observe the metrics. On the node side, we randomly reboot a node. That's how we identify, hey, if the DNS is good, or if the customer also, is there any noise from the customer, or their pods are gracefully shifted to another node. So having this practice helps us to react in a situation when there is a production instant, like we can quickly jump on it and kind of address those problems. So these are some of the activities we do to avoid major outages. I hand over to Suresh.
Thanks, Nanda. Okay, this is like a scripted environment where we run the game day testing. Like it's pretty much chaos engineering you can think of, all right? We would like to, we are planning to write a product out of this where it can be used by across everyone, where you can just run this, it'll reproduce these environment scenarios and then say that what is your cluster behavior. Cool. Before I go here, there are many scenarios which we ran into. There are a few. Please talk to us. I'll be here for a whole day. We could discuss about what's the Docker issue we ran into, what's the ingress issue we ran into, or the network issue we ran into, right? So pretty much all those things which I discussed about the component which we built internal is pretty much out here. It's kind of open sourced. It is built so that we can contribute back to the community rather than just always not observing it. So please do use it. It's pretty much, and then we are in the process of see if we can open source the ingress controller as well as for the ATS, Apache Traffic Server. And geeking out K8s at what? I just talked about our experience, right? But we have done templating engine, how we templated. And we have our own networking model of how did we do the networking for Kubernetes. And we have our own I talked about ingress, a way of how do we manage clusters, what are the tools we built out of it, how is our identity provided, right? We provide a very unique identity, short-lived identity for the workloads, right? So our engineers just deploy their application, we provide an identity for that. We call identity, other codes are out there, open sourced. So that if you want to get the complete view of how we are doing end-to-end Kubernetes, please click on this particular link. We had a detailed discussion about how each components we have been doing. And this is my mail ID. Please reach out to me. I'm very much happy to collaborate. I pretty much join all the Slack channel. I'm always active out there. In case you want to talk to me, please reach out to me. And important, I'm hiring, right? If you want to solve the challenge with through automation, please do contact me, and we can talk about your possible opportunities there. Thank you.